Shall we start?
Yes, absolutely.
Yeah. Hi everyone. I welcome you all to the third week of Data Science Talks by Women in Data Science Noida. Women in Data Science is a global initiative by Stanford University. It aims to inspire and educate data scientists worldwide, regardless of the gender. It was started as a one-day technical conference. 5 years later, today, it has more than 150 plus regional events in 60 plus countries, over 1 million participants. I am Shubhika Bhardwaj and I am your WIDS host for this session. I am a software development intern at SAP Labs. Being a machine learning enthusiast, I have also been to conferences and hackathons. I am one of the Google Travel Grant recipient for TensorFlow Dev Summit. I have also been one of the finalists at Hack In Out. Now, I would like to introduce our speaker for the session, Ankita Saraf. Ankita Saraf is the very marvelous name in data science today. She has over 6 years of experience in various data-centric roles like advanced analytics, data warehousing, and data lifecycle management. She is currently working as a data scientist at Volkswagen and has previously been associated with organizations like Indian Statistical Institute, TCS, and Adobe. She has a bachelor's degree in computer science engineering and has an advanced management in business analytics degree from Indian Business Schools, Hyderabad. And we would like to share this detail with you all that one of our publications, Separation of Text from Non-Text Doodles of poet Rabindranath Tagore's manuscript, is one of the publications that has been recognized by a huge audience worldwide. We can begin now. Over to you, Ankita.
Thank you so much, Shubhika, for the introduction, and good morning, everyone. Thank you for joining on a Sunday morning. And I would actually start with the topic right away. So today we are going to discuss uh, data versus data, hype and the reality. So this topic mainly entails what the hype is around the data and what the hype is around the various data topics that we are looking at today, like data science, AI, machine learning, and so on, and what actually is the reality of all of these hyped terms. So I would like you all to think about how AI is being used in our day-to-day lives today. And in the meanwhile, I'll give you just a sneak peek of my data journey so far. So I started off with a BTech in computer science, like most of the Indian students, and then as a part of my course, I also did a research project in ISI Kolkata. I joined TCS as a systems engineer, and then I moved on to Adobe Systems as a data analyst and then a business analyst. After that, I did an advanced management course in business analytics from Indian School of Business, Hyderabad, and currently I am working as a data scientist at Volkswagen. So now we'll directly jump to our topic for today, and I would like to tell you, like, we have all heard about AI and data and the world of infinite possibilities that it shows us, and how it is an inseparable part of our daily lives nowadays, starting from, say, the wearable devices that we use every day to track our steps, to intelligent homes, to the complex self-driving cars, which is one of the most focused areas of today's world. So let's dive deep into what it is all about. It might seem quite overwhelming in the beginning, but we will try and decipher what is true about it. So let's proceed with the agenda for today. So we will talk about the hyped conversations that we have. Some of us might be a part of those conversations, and some of us might have just heard about it. And then we'll identify what do they really mean what are all these jargons that people are talking about in our daily conversations. We then move on to AI. What is the interest of people in AI and how they are able to adopt it or not adopt it? And why is there a difference in the interest shown by different organizations in AI and the actual adoption rate? Then we move on to the role of data in all of these, the conversations, the interest, and the adoption of AI. So this is something I think many of us would be familiar with, where anyone that you meet on these days is talking about blockchain, and they talk about how it's going to help you, how artificial intelligence is going to help you. But once you want to deep dive and understand what they want to talk about it, they typically change into different jargons that they want to use, and they might not actually know what lies underneath. So this is an example of a hyped conversation that we'll talk about, and this is the kind of conversations that many data experts have to deal with and actually make sense of. So one of that is somebody saying our goal is to make our solution AI driven within 5 years. We want to use AI to predict fraud, boost sales, retain customers, reduce attrition, and so on. Then there are people who quote numbers because statistics always make you think that it must be true. So it's like organizations investing in AI, they realize an X% revenue boost. And then there is something which goes like, we need to invest in AI and the emerging technologies so that we are not left behind our competitors, and we need to retain our brand value, and so on. But what is common between all of these conversations? What is it that is the focus and how it confuses people? It is the buzzwords. So there are many buzzwords doing the rounds these days, some of which are data cloud, Internet of Things, artificial intelligence, IoT, machine learning, chatbots, blockchain, and so on. But do people really know what these mean, or are these only there for the star power that they can generate? They lead people to thinking that they are doing something really out of the ordinary, and everyone is attracted to such words which create a lot of hype for the person who is using these terms. But in reality, all of these, if you look at it, are just a complex set of algorithms that people are working with. So let's try and understand what do these words actually mean. So basically, all of data science is about four things, that is artificial intelligence, machine learning, deep learning, and at the core of it all is the data that you have. So artificial intelligence is basically a technique which enables a machine to think or mimic a human behavior. So it is something that we create as a result of a project or as a means of a solution to a business problem. We then have machine learning, which is nothing but a set of algorithms or statistical methods which enable the machines to improve with experience, which means we feed a lot of data to the machine. The machine learns through the set of data and its outputs, and then it makes changes and improves its results and the output that it gives based on the experiences and the insights generated. Then we have something which is called deep learning, and deep learning is closest to the human behavior that we have reached because it is based on how the human brain works, and it uses a multiple neural network, and it's used widely in, say, image recognition, in virtual assistants, chatbots, and so on. But let me tell you one thing, all of these complex technologies are based on the data. If the data is not correct, if the data is not sufficient, however complex algorithms that you may move on, whatever you may design, it will not give you the desired results. So, and none of these technologies, I would say, are very new. Some of them have been there in the world from as far back as 1950s. It's just that with the increase in computational power, they have taken on a new avatar in the world. So let's check out the hyped conversations that we have. And once we understand what artificial intelligence, machine learning, and all those buzzwords really mean, what do these conversations move to? So whenever somebody says that we need to make our solution AI driven, what they really mean is that we need to design a couple of machine learning models and put them into production within the stipulated time. When they say they want to use AI to predict a number of things, what they really mean is they want to incorporate a logistic regression model to improve these areas. And when people quote a X% revenue boost, what they really mean is that they want to incorporate any kind of predictive model in production and realize a revenue boost, because when you have such automated models in production, it reduces the manual effort, things are calculated easily and efficiently, and that results in an increased revenue. When we say that we need to invest in all the AI and emerging technologies, what it really means is that they want to use machine learning to improve their customer segmentation. And when they improve their customer segmentation, they know whom to target, how to target. They can work on their marketing strategies and the sales strategies, which will ultimately lead to an improvement of their business. So now let's again get to a talk about the statistics, because yes, that's important. So yeah, we might have heard statements like these a lot, that the AI market will go to so many like this billion industry by the end of this particular year, and so on. And this is a study that comes out almost every year, where there are a lot of predictions on how the AI market is going to grow, and people follow it religiously. But let's take a look at this graphs where McKinsey basically did a survey, and it identified that around 84% of organizations believe that AI will definitely give them a competitive advantage and it will improve their business performances. But on the other hand, if we look at the second graph, and we see that the leading sectors who have adopted AI in the business processes and the products have barely reached a 30% adoption. So why is there such a huge difference in the interest and the actual adoption of AI? Because everyone that you hear about is working on it or trying to work on it, or incorporating AI. So there are various reasons for this, and one of the major reasons for that is the data, the underlying data that we have. The various organizations, they fall short of the data, or they design really complex things, but the data does not help them or does not contribute. And that leads to a difference in what output they are expecting on what they are actually getting. So what is it about data that they need to work on or they need to improve so that AI adoption sees a major change and a major increase in the current scenario? So what I like to call it is BUTS. It's like you have the technologies, you have the data, because there's a lot of digital data out in the world today, and so much of data is being generated every second. But there are still something that needs to be checked out, and we need to kill these bugs so that we can improve the adoption. So these are basically bias in the data, the understanding, the representation, and the data literacy that it's known as. We have the training data that we have for feeding into these models, because all of these machine learning and deep learning models are actually data hungry. You have to feed them a lot of training data for them to actually make sense to you. And then we have strategy, the data strategy that needs to be in place before you can actually make use of the data that you have, and you can gain insights which will ultimately lead to better business decisions. So let's get into each of these in detail. And we can start off with the first one, which is bias. So, bias is basically the interference in outcomes of research based on predetermined ideas. And these could be prejudices, these could be a problem with the data you're handling, these could be something which you take a sample and that is not representative of the entire population that you want to look at, and such. One of the major examples of bias in the data was observed by Amazon, and it was something that Amazon had designed a recruiting system wherein the algorithm was designed to take in the resumes of people and sort it according to the requirements that the organization had. Now, the problem with this recruiting system was that the data that was fed to the recruiting system as a training data had more number of resumes of men. So when it actually was tested, what happened was it removed those resumes where there were mention of, say, women, say somebody in the women being in the women chess team or women's sports club or something like that. Those resumes were removed at the very beginning of the funnel. So now something that is removed at the beginning of the funnel does not go to the screening or the interviewing and the selection process. So once they realized this bias in their algorithms, they had to do away with the entire recruiting system. They had to scrap the project, and there was no way that they could do anything about it because their data was flawed. So moving on to the next example. So this is basically a picture of a US military aircraft which was used during the World War II. So now during the wars, what happened was whenever these fighter planes were sent on missions, some of them returned with damages to these specific areas. So the areas represented in red are the areas where these planes were damaged when they returned from their missions. Now, the US military, they wanted to put armor on these planes so that they could protect the major areas wherever, like when the aircraft was hit on those areas, they could basically survive. Now, they could not put the armor on the entire plane because it was very heavy and that would interfere with the flight operations, and also it was quite expensive. So they wanted to identify the areas where they wanted to put the armor. So now there were areas like marked over here, A, C, and E, where they were not majorly hit. And there were areas like B, D, and F where they were majorly hit. Now, the personnel from the US military and the commanders, they wanted to armor the plane at B, D, and F. But there was one person from Columbia University, Mr. Wald, who was a statistician there, who had a different opinion, and he wanted to armor the planes where it was not hit. Now, the reason that was quoted by Mr. Wald was that the US military was not considering those planes which did not return from their missions. Those were the planes which were hit and they could not survive. Whereas the data that the US military was considering was only for those planes that had survived the hits and had returned. So basically, any plane that was hit in the areas of A, E, or C did not survive and could not even return. So armoring those areas would probably be the best option for the US military. And this insight ultimately led to saving a lot of lives in World War II, as well as in future wars in Vietnam and Korea. So what this basically means is there are a lot of times where we forget to consider the entire population before extrapolating our sample data. We forget to use those cases which do not come into the picture at all. This leads to a bias in the output, and this can lead to entire projects being scrapped. Now we move on to the understanding of the data, or as we like to call it, data literacy. So data literacy is basically understanding graphs, making sense out of it. Because we all know that in the current, like in the real world scenario, all that everything moves to is the CEO at the end of the day wants to check out a few graphs, understand the insights, and then make decisions based on it. So it's a very important part of any project that is there. So like we have two graphs on the screen right now. And when we look at the first graph, we see that there has been a drastic improvement in the interest rates from 2008 to 2012. Whereas the second graph, if we see, there is hardly any difference in the interest rates from the same period of time, that is 2008 to 2012. Now, what is the difference between these two? When we look at the first graph, we are really impressed that there is a lot of improvement. But actually, these two graphs are based on the same data. The difference is that in the first graph, it has a faulty y-axis where the y-axis has been altered, and it's made to look like there is a lot of difference where there isn't. Now, such representations can throw the insight haywire and can lead to bad decision making. And we should steer clear of such things. Now, then we move on to the training data. So why do you think Google's algorithms and all the products that Google has have such good recommendations or such good value in the market? They are widely used. So in the words of Google's chief scientist, Peter Norvig, they do not have better algorithms, but they have more data, because Google has been involved in data gathering from a very long time, and they have excellent data. So let me give you an example from the current scenario that we are all going through, the COVID, which has led us all to be at home. So this is one thing that happened with when the COVID started in January 2020 in China. So this was the data taken over a period of 15 to 16 days in the month of January from the actual confirmed cases and the actual deaths. And based on this data, there were a lot of predictions that were made all over the world. And this is the prediction that was made following the month of January for 7 days, 14 days, 30 days, and 45 days. Now, if we see the actual number of confirmed cases at the end of 45 days, we see that the prediction was wrong to an extent of five times the number. How did this happen? This should not have happened when you are predicting something as critical as a pandemic. But this happened because they had very few data to predict something. They have 15 days of data that they are using to predict a more than 45 days prediction. Now, how does that throw you off guard? Because you do not take into account the various factors along with the data at hand. There would have been a change in the environment, there would have been a change in how people behave, and there would have been many other factors or things that have not been taken into consideration while making that prediction. So this is something that we need to avoid. And how do we avoid it is if we have more training data. And that data should make sense. It should not be anything random. More training data does not necessarily mean a high number of data rows. It might mean more number of factors, more number of variables that you are looking into, which might affect the ultimate result of your prediction. Then we have something that is the data strategy. So most organizations that are really doing well in AI and have incorporated it into their products have have taken multiple years to reach this level because they have been gathering data, they have been acquiring data, cleaning them, and making the best use of it as they can over multiple years. This is not something that can be done suddenly. You have to have a plan in place, and that is where most of the organizations lag behind. They just want to get onto the hype train and do something in these technologies, but they lack the base and the structure for it. So how do we make a data strategy? What do we start with? First thing is, you have to collect your raw data from multiple systems, and these data might not in the beginning seem connected, or it might be very difficult to organize them. Might be very different from one another, but you have to gather all of the data at one place. You have to clean the data, you have to normalize and aggregate the data so that it makes sense. You have to make use of, you have to identify the missing values, you have to replace the values, and you have to actually make sure that the data that you have is actually useful to the business problem. There has to be a link between the business problem, the core strategy of the organization, and the data plan that is in place. Then whatever cleaned data that we have to go through a lot of sifting and selecting of the data, because not all of the data will make sense. And once you sift and select the data, you might realize that there are a lot of things that are missing from the data which would be needed for you to solve the business problem at hand. So this part also entails a lot of business knowledge. So you would need experts in the area to identify what is useful and what is not. Now you move on to developing the algorithms, testing and fine tuning it based on the different sets of data that you might have. And this is an iterative process. So this process does not stop. You do not just stop at, you know, collecting the data. You have developed the algorithms. There are times when you have to go back and forth a lot in these steps. Once you have developed the algorithms and tested them, you create dashboards and try to identify what insights are you able to get out of data. This is the time when you actually ask action-oriented questions and try to understand if the dashboards that you have created and the data that you have, the algorithms that you have developed, are in any way helping the business, and are they solving the problem that you started off with. You try to get actionable insights from your data and whatever you have processed in the meanwhile, whatever models you have developed, and post that comes the decision making part. So this is how you develop a strategy, and without this, it's really difficult to adopt AI into the product and the processes of an organization. Now, lastly, what I would like to say is that the hype around AI and the data that is there, it makes it really hard to understand it. It overwhelms most of the people, but they still want to go with it because that is the trend that the world is following. So there are a few points that we need to understand in order to cut through the hype and get the real value out of the data at hand and actually adopt the technologies that are there. And the first one is the usage of the term artificial intelligence. People really need to be careful how and when they use the term artificial intelligence. Not everything that comes into the picture as an automated process is artificial intelligence. The second term is scare tactics. What this basically means is, like, most of us would have seen headlines in the newspaper all over the internet which says, the AI boost is going to take away our jobs. People will be jobless. Everything will be done by robots, and so on. So these are just attractive headlines created by the marketeers to attract the audience, because something like that will obviously make you click on that and read through it and something. But it does not necessarily mean that AI will take away our jobs. Yes, there would be a change in how jobs are done, if there would be a change in the job profiles, and people who are not updated or do not want to make a change will definitely fall behind. But while there will be a shift in the types of job, there will be a lot of jobs that will also be created along with it. So it does not mean that people will not have jobs in the future. So these are just to scare people into adopting things. Then we have the fact that some AI companies don't actually use AI. So their products will be marketed as AI driven solutions, but they are actually not AI driven solutions. They are just automated things, automated products, automated processes. But because they want to create a hype, they use such terms to just go into the market, create a hype, and make people adopt these things. So yeah, that's all from my end. And you could connect with me. You could ask me questions. Over to you, Shubhika.
Thank you so much for such an amazing and insightful talk, Ankita, and we are really glad to host you today. Now we can move on to the question answer round, and we have a couple of questions from the audience. The first question is data science versus software, which is better?
I mean, softwares are designed based on these technologies. Data science is a vast area. Data science is a vast area which encapsulates everything from collecting data to cleaning data to data engineering. You know, you make use of the data, you apply statistical models and everything. And any software that you see in the market is a result of some of these things that is automatically done by the software. So you make use of these technologies to design something which can be sold in the market as a software.
Yeah, I completely agree with you that we have softwares that utilize data science to improve their functionalities or like their results, or we can have softwares that predict various scenarios, or like they analyze our data. So yeah, so
Absolutely, yes.
everything related to
So
software
software is
today.
the end product.
Yeah,
Software is the end product.
yeah, definitely. Now we have some couple of open questions, so I would read them out to you.
Okay, sure.
So the first question is, in the strategy that you talked about, what is shifting?
It's not shifting, it's basically sifting or selecting what makes sense to you. So you may have a lot of data that is there, that is dumped on, but when you go through it, when you clean it, when you perform an exploratory data analysis on it, you realize that some of it might not make sense or might not be useful in the future when you are trying to develop a model, when you are trying to design an algorithm. Those particular things might not be useful to you. So you do away with that so that your algorithm can probably is not just heavy because of the unnecessary data that you might have. So you have to make a few decisions where you clean up the data. So that is something also termed as feature engineering, where you
Yeah,
only take on the features that are useful to you and you avoid the
yeah,
rest.
yeah. So I agree with you that it is all about selecting features that are required and avoiding those which impact your models in a bad way. They lead to bad predictions. So we can
Right.
avoid that and select important features.
Right.
Uh,
So a lot
Summarizing
of
it, that it is feature engineering. Yeah,
yes, yes, absolutely.
add
And a
on.
lot of business knowledge also comes into the picture here because when you look at the data, there are a few things that you might think will impact your decision making and will impact your model. But, you know, uh, if you have knowledge in that area, you can already identify based on your experience what might and might not make an impact.
Yeah. So it is definitely that data scientists don't work in a sole and single-hearted way. They definitely get in
Absolutely.
contact with the business leaders or people who have enough business knowledge, and they can help them guide on which features to select and which to avoid. Moving
Yes.
ahead with the next question, yeah. So we have next question from Prachi. I work in a corporate strategy and I want to learn data analytics too. I am from a finance background. Can you recommend any tools or any approach that might help analyzing data better?
Absolutely. So basically, people who are into the finance or corporate or anyone who has been working, I would say the best tool that they can use is Excel sheets. Excel sheet in itself is a great tool to use if you can make good use of it. And there are various other tools in the market. A few data visualization tools help in such scenarios, and you could select from anything that is available, say Tableau, Power BI, or any other data visualization tool which can help you analyze the data better. And if you actually want to get into uh, more core technologies, which I doubt because of the finance background, but for people who are into engineering or coding stuff, Python and R are the best tools to use for the same.
Yeah,
I hope that answers it.
yeah. So we will move ahead with the next question now. We have a question from Kashvi. Do you think young researchers are being swayed away because of the hype around this field? How do you suggest one to not be overwhelmed by the abundant information or false opportunities?
Yes, this is one of the major things that is happening today, and not only with young researchers, with people who have also been in the field, they are quite easily swayed because, for as a matter of fact, these technologies they are, modified, or these are so quick that by the time you actually, try to focus on something and get a hands on and become an expert in this, these technologies become obsolete and there is something new in the market. So yes, a lot of hype is being created because all these so-called buzzwords and star words that are in the market. And I would say yes, to some extent, you need to understand. You need whenever you hear some word, just get into the depths, understand what they actually mean, because these words are being used interchangeably. People refer to the same thing when they are talking about artificial intelligence, machine learning, deep learning, everything means the same to them. So you really need to dig deep and understand what do these terms really stand for. That will help you in the long run. And another thing is that data science or AI is a huge field. You cannot possibly know everything, so it's better to focus on maybe a couple of topics that really interest you rather than go by the market and try to learn everything at once. Just take small steps in the direction. I think that
Yeah,
should help.
I would like to add to Ankita's answer that machine learning today might include topics like deep learning, convolutional neural networks, RNNs, neural networks, NLP, and the list goes on. There are things like computer vision coming up, and these buzzwords try to attract youngsters to the field. However, due to excess information, they are overwhelmed and don't know which technology to go with, and that's when people don't use the data science opportunities available to their advantages. So I would like to advise all the youngsters around listening to us in the audiences or live chats that it is all about going in the data science field if you have the passion for it, and if you understand that this is the technology I want to work with, and try to develop a niche. Yeah.
Absolutely. The first thing
And
to understand is that
yeah, we
whether you
can.
are really interested in it, because this is something that you cannot do if you're not curious enough in the area. It's quite complicated that way.
Yeah, I completely agree with you.
Yeah.
We can move ahead with the next question now. The next
Yes.
question is, uh, how do we know that our data has a bias? Since we get data, we train it using various models, and all we can see is predictions or conclusions represented by graphs. So, how do we understand that we have a bias in our data and how to avoid it?
Yes, absolutely. This is one very important step. And what this requires it that you have to spend enough time in the beginning when you just get the data. So you would have heard that most of the data scientists spend 80% of the time cleaning the data. And let
Yeah.
me tell you, that is the truth. Because when you have such overwhelming data, you need to spend some time to understand what that is. The best thing here could be understanding the data generating process. Where is that data coming from? So, if you know how the data has been generated, you will probably understand, or you will be probably able to judge if the data is biased. Say, for example, if there are a lot of whenever you have a new product in the market, so there is a market research that goes on, and they survey a lot of people, and say you have surveyed say 200 people from outside a college, and based on that survey you try to say that, yeah, product A is doing much better in the market than product B. But those 200 people do not represent the entire population, right? Those 200 are just, if you are outside a college, those 200 would probably be the people with the same kind of financial background, same kind of mentality, same age group, and the same area probably. So this data is not sufficient to make your predictions or to be used in an algorithm or to be used in a model that you are designing. So your data needs to be diverse, and before you make any conclusion or you draw any insights from the data generating process is something that you should really look into.
Okay. So, I completely understand on how you pointed that we should go deep on how the data is being generated, what are the data sources, from whom we collected the data or generated the data from, so that we are able to understand whether our data is biased or not. And then we can move ahead with the predictions. Yeah, thank you for answering that. We have another question from the audience. Um, Harin asks, how can we choose our research domain considering the hype? There are wide domains of research like machine translation, natural language visualization, and a lot more.
Okay, so for this, it's like all about your interests because it's such a wide world out there if you consider everything. So there is NLP, there is deep learning, then within all of these, you have particular, there are people who only work on logistic regression, and there is so much to learn in logistic regression itself. So this completely depends upon your interests. And to tell you the truth, I have been here for quite some time, and even I get overwhelmed. Like sometimes when I am working on, say, a deep learning project, and I'm thinking, okay, I do not know anything about NLP. Let me learn something about NLP, and then I'll go and try my hands for a few days on NLP, and then if it doesn't interest me, I get back to something on deep learning. So there is no, sure short way of identifying it. You just have to try your hands and identify where your interest lies.
Okay, I hope that answers your question, Haran. We have another open question. The question is like this: how we can select which training data to use? Like sometimes we have the data from within the organization, we have external data from like public data sources, we even have government related data. So how do we know which data is better for our training purposes?
So, for this, I would say that there is no data which you can consider as a good data or a bad data or a correct data. It all depends upon what your business problem is and uh, what data you think, or based on your experience, would actually help you out in solving that business problem. So when I say that there are many organizations that face a lack of training data, so it's not necessary that all that data comes from a single source. So there is organization data, and it might not be sufficient. Organized data might need to be supported by publicly available data sets, or it might need to be supported with government databases. So it all boils down to the problem that you have at hand.
Okay.
So you
Yeah.
need to connect these data and how do they make sense to you.
Okay. So
That is
I
how you
think,
identify.
yeah, I think it is all about going, focusing on what our problem is and what is required by our business or administrative teams, and then we can focus on which data to use and which predictions to make actually. Yeah.
Absolutely.
So we have another question.
Sort of
It
trial and
says,
error.
yeah,
So
we have another question. It
yeah.
says that how to fine tune our data models.
So fine tuning your data models, that is a process. That's a very repetitive process. So once you have the data which you think makes sense and which you think is clean enough to be used in your algorithm, you apply some algorithm, you apply some logic, you create a model. Then, based on the model that you have created, you have various factors on which you test the models, whether that model is giving you a good prediction, whether it's giving you the desired results, and everything. So, there are various parameters on which you judge your model. And as per my knowledge, there is never a case that you just try one algorithm or one model on the data set that you have. So you have to try different algorithms, you have to try different parameters on the same, and you have to see which one works on the data. Another factor that comes into the picture here is there is a lot of difference on the training data and the actual data on which the model might be working. So something which gives you really good results on the training data might not give you the same results on the testing data. So there is no hard and fast rule that you can follow here. It's all a trial and error method. Whatever works best for your data, whatever best works for your business problem.
Yeah, I can emphasize that we have a training data and a validation data, and if our model works well on the training data, it might not perform that well on the validation data, and that's when we know that we have undergone an overfitting situation, and we might fine tune our model, change certain parameters here and there, and lead to better predictions. So yeah.
Right. Absolutely. You need to have a trade-off between the, accuracy of the model that you are using.
Yeah. I have another question. From your experience at Indian Statistical Institute working on a research project, how do you encourage undergrad students who are enthusiastic in the data science field, how they should start up with research interns or research projects, and how are they different from normal data science projects that a student works on?
Okay, so my experience in Indian Statistical Institute was way back in 2012, and that was done as part of my undergraduate studies. And what I feel is like, when you get into research, what you are actually working on is something that nobody has worked on, or maybe basis on a lot of research papers that you look into, and something you have to come up with something on your own, which is different, which is not done by anyone else. As compared to when you're working in the real world, you have a lot of resources at your disposal which you can replicate. There might be a lot of people who have actually worked on that, and you get ideas, you get maybe an already made project which you need to tweak, which you need to adapt to your business area and what you want to do. So what happens is you have a background. that makes things easier. You know what a lot of people have done and how that has helped them, and what is the benefit that they made out of it. But when you're doing a research, it's a totally new thing. You do not have a background. You only have maybe a research papers. You get a starting point, but from then on, it's your show. What you make out of it, how you develop it. You cannot replicate anything in case of a research. So that's totally your work and your team's efforts in that.
Okay, I have a follow-up question for this. When we are
Okay.
working on such a research project with no background, mostly one starting point, then how should we progress forward daily? Like, we do have a mentor during our research projects guiding us to, work in this direction or go with that. But how do we, as individual or as a upcoming data scientist, learn to progress daily on our research projects?
That's the reason you have a research mentor, because
Yeah,
that person has been there. And usually if you see, in case of research projects, the mentors are usually very experienced in the field. They are usually PhDs. They have a lot of publications at their hands, and they know, they have enough experience to understand how to take things forward, what direction to think in, right? And that is the reason they can guide you well. In research, what happens, you do not have something to work on daily. There
okay.
might be, there are times when you just feel that this is a dead end. Maybe we have used a wrong approach, and you get back and you do the entire thing again in a different way. Like it happened with us when I was working in ISI. We thought of a business problem and we started, coding in MATLAB, because that was something that was upcoming at that point of time, and we were learning it, and we started coding in MATLAB because we thought that is the way to go. 1.5 month into coding in MATLAB, we just suddenly realized, that there is one thing that doesn't work on MATLAB. There is no functions that's going to work on MATLAB. And then we had to change our entire approach and start from scratch. And we started coding in C and C++. So that is where, a research thing takes a longer time, because it's a new approach that you're using. You do not know
Yeah,
who to.
that answers my question. And thank you for sharing your interesting story with your experience at ISI. And I'm really motivated to go forward with more research projects and opportunities that I have ahead of me. And I would like to thank the audience for being so engaging and attending this talk by WIDS Noida. On the behalf of entire WIDS Noida team, I would like to thank our marvelous speaker for today, Ankita Saraf, and I would request the audience to stay tuned for the evening session. And thank you. We would like to conclude this session now. Ankita,
Thank
any
you so.
closing notes?
Yeah, absolutely. Thank you so much. It was great being a part of this session, and obviously I look forward to many more sessions like this. And I would also like to thank the audience who took out time from their Sunday morning schedule. And yeah, it's been great. And if you have any more questions or any time that you would like to connect with me, you have my LinkedIn ID and you also have my email. Please feel free to drop in a text or, talk to me anytime. I'll be glad to help. Thank you so much.
And we definitely have more sessions from Ankita. We are like more than excited to host her again. And thank you so much for your time and valuable insights into the data science industry. Thank you so much. We are ending.
Thank you. Have a great day.